All right, welcome to the Explainer. Today, we're digging into the really clever engineering behind OpenAI's coding agent, Codex. You've probably seen it in a bunch of different places, right? So we're going to figure out how one single AI brain manages to power all these different applications. It's a fascinating story.
So for all you developers out there who basically live in the command line, Codex is right there with you. I mean, its first home was actually a TUI, a terminal user interface. You could just talk to the agent directly from your shell.
And then, of course, for a more seamless experience, it's also this incredibly powerful coding assistant that just sits right inside your IDE, like in VS Code, helping you write and debug your code in real time.
And to make it accessible to pretty much everyone, it also exists as a full-on web application. You can get all its power right from any browser. Super convenient. Okay, so this is the big question, right? How can one AI brain power all of these things? You've got a terminal, a code editor, a web browser. They're all totally different environments. They all speak different languages. So what's the secret sauce here? Let's get into it. And what's interesting is that the answer wasn't some grand master plan from the get-go. Nope. It was actually a really elegant solution that came out of a very practical problem. A problem that just got bigger and bigger as Codex took off. So here's how it all went down. It started out super simple, right? Just the terminal app. But then they built the VS Code extension, and bam, they hit a wall. They couldn't just rewrite the whole AI logic from scratch. That would be crazy. They had to reuse it. Their first few attempts to kind of Frankenstein things together were, well, they were clunky. And then as more and more partners wanted in on the action, the pressure was really on to create one single stable solution that just worked for everyone. And this quote from Celia Chen at OpenAI really hits the nail on the head. This was the turning point. The team knew they needed a platform that was super reliable, backward compatible, basically a solid foundation that everyone, whether it was their own internal teams or external partners, could build on without worrying that some future update was going to break everything. So that brings us to the solution they created, the Codex app server. You can think of this as the magic link, the thing that connects the core AI brain to all those different front ends we saw earlier. Honestly, the best way to think about the app server is like a universal translator, but for code. It just sits right in the middle. On one side, it's fluently speaking the language of the core AI, and on the other, it's speaking the language of whatever app it's plugged into. It's the ultimate go-between. And this is how that whole communication chain works, step by step. So your app, let's say it's VS Code, sends out a request. The app server catches it and translates it into a language the core AI brain, which they call the Codex harness, can actually understand. Then the AI does its thing, works its magic, and the app server translates the results. We're talking code diffs, progress updates, you name it, back into something the app can show you. It's this constant two-way street of communication. Okay, but for any good translation to work, you need rules, right? You need a shared language with some clear grammar. And for the app server, that language is built on 3 core ideas. They call them conversation primitives, and they basically structure the entire back and forth. So first up, you've got the thread. The easiest way to think about this is it's the entire ongoing conversation. It's like the complete chat log you have with the agent, the container for the whole session that can be saved and picked up later. Right. And then inside that thread, you have a turn. A turn is just one single back and forth. So you ask Codex to do something, like, hey, run all the tests and tell me what failed. Everything that happens from your request until the agent gives you its final output, that's one turn. And finally, we get down to the smallest piece of all, the item. Think of an item as a single message bubble in a chat. It's one atomic unit. It could be your message, a chunk of code the agent wrote, or even a little pop-up asking for your permission before it does something. Every single part of the conversation is an item. Okay, so now that we have the rules of the road, how does this whole universal translator thing actually work out in the wild? Because it's definitely not a one-size-fits-all solution. And this is where it gets really interesting because you can see the 2 main ways they do this. On one side, you've got your local IDE integration. On the other, the web app, and under the hood, the way they're built is completely different. So for your local stuff, like the VS Code extension, the app server is actually bundled right in with it. It runs as a little child process right there on your own machine. But for the web app, it's totally different. The app server runs in a remote container, out on the cloud somewhere. This is genius because it keeps your browser super lightweight. And, this is the best part, your session stays alive even if you close the tab or your Wi-Fi dies. You can just pop back in and pick up exactly where you left off. No lost work. All right, let's zoom out for a second because what they built for Codex isn't just about Codex. This is a powerful blueprint, a recipe for how we can build really rich interactive experiences with pretty much any AI agent down the line. And for any developers watching who want to get in on this, OpenAI is pretty clear. The app server is the top-tier recommended way to get the full-fat Codex experience. But as you can see here, they do have other options for more specific use cases. Like a super lightweight tool for your CI/CD pipeline, or maybe an SDK for server-side stuff. Their choices. So what's the big takeaway here? It's this. If you want to build AI agents that are more than just simple chatbots, if you want something truly interactive, you absolutely need a solid communication protocol. It's got to be stable, it's got to be a two-way street, and it has to be amazing at translating all the complex stuff happening inside the AI's brain into an experience that feels totally smooth and natural for the user. And really, this quote gets to the heart of why they did all this. This whole engineering project wasn't just to make one product better. It's about creating a standard, something that makes it way easier for all developers to build their own powerful and useful AI agents. It's about making this technology more accessible to everyone. Which leaves us with a really fascinating question to chew on. As AI agents become totally commonplace, as normal as using a database, is this universal translator model, this app server architecture, going to become a standard piece of the puzzle? A tool that every single developer needs in their toolkit? Because this really could be the blueprint that defines the next generation of how we build software.